Hi, my name is Oluwasegun Adebayo. Feel free to call me Adebayo. I'm a data analyst, and today I'm going to be walking you through what I call versatile exploratory data analysis. This is one of the code that I use on a daily basis in my various projects. And exploratory data analysis is one of the most important analysis that you're going to be doing on a daily basis. And simply because I use this on virtually all the projects that I work on. So I eventually develop a set of functions that I use to do exploratory data analysis. Why do you need EDA? EDA is very important in the sense that, let's say for instance, the people that you are working on, let's say the manager walk up to you and say, "Oh, Adebayo, this is the data we got from the marketing. This is the data we got from this is data. This is the data about this. This is the data about that." So oftentimes they bombard you with a lot of business questions. Please, we want to know how does this happen? What's the average for this? What is the trend of that? So if you are not careful and you go ahead just trying to answer those questions directly, you're going to run into a lot of problems. Why? Because you'll be uh, you'll be doing blind analysis in the sense that you won't know the structure of that data, such as do the does the data actually have some missing values? What is the pattern, the structure, shapes, and the like? So that is when the exploratory data analysis code actually comes into play. So this is one of my code, and the code I will explain first and foremost the code to you. I've already written them, so I'll be explaining each line of the code. And the other thing that I did was that I heavily commented the code, so it's quite. I'm pretty sure you're going to find it easier to understand what I did in each line and what each line of the code actually does. So versatile exploratory data analysis code is a set of functions designed to facilitate data exploration and analysis in Python, primarily using the Pandas, Matplotlib, and Seaborn libraries. So it offers a comprehensive toolkit for you to gain insight into your data quickly and efficiently. So the code starts by importing essential data analysis and visualization libraries such as Pandas for data manipulations, Matplotlib for plotting, Seaborn for enhanced data visualization, and NumPy for numerical operations. So it then defines a series of functions to perform common data analysis. Now, I call it versatile in the sense that what you only need to do is just to supply the data and then you run the entire code. So it's going to show you the key information that you need from the data actually, without you necessarily writing the code uh, operation by operation. So the first function is called load data. This function loads the data from a CSV file and returns it as a pandas data frame. Of course, the code is so flexible in the sense that you could use other formats. Probably your data is in uh, test file or something. So feel free, you can modify the code, but is that I don't think that should be a problem. Then the second function display add the first 5 rows of the data. Then uh, the third function is a get shape. The function prints the dimension, number of rows and columns of the data frame. Then get missing values is the fourth function. It identifies and prints the number of missing values in each column of the data set. So yeah, so without wasting much of our time, let's get started and then and see how the code actually works and function. So these are the libraries that we're going to be using. The pandas, import pandas as PD, then import matplotlib.pyplot as plt, then import seaborn as sns. These are a conventional way of importing these libraries. Then import numpy as np. Okay, so let's run it. So it ran successfully. Then So the second function basically is called loading data. So, and we define, first and foremost, we define the function name, which is load data. Then the argument is the file path where you've actually kept your data. So it takes the file path as its parameter. Then this function is used to load data from a CSV file and return it as a data frame. So what we're going to do now is we assign this the file path. First and foremost we read the data from the file path. Then we assign it to data. Then we actually need to just return the data, so that this data we're going to be using it in the subsequent functions. So if we run this, so it runs successfully and everything is fine. So the third function basically, we define a function called displayHead that takes data, the outputs of the outputs of the second function. So the third function takes it as its argument and an optional n parameter. So this n, you may choose to make it 10, 15, or any number you want. So in this case, usually I just preview the first 5 rows of my data. So it takes in the data, then the number of rows to return. So then we print using the string formatting method. So we print the in this case now it's going to print first 5 rows of the data, then data.head. So this is the function we use to preview n number of rows in our data. So this function will necessarily not return anything. Instead, it will actually just print out the first 5 rows of the data. So if we run it, so everything is successful. These are functions, okay? So we don't need, there's not going to be any output yet until we call the functions. So the fourth function is called get data shape. Why do we need the data shape? Well, you need to know the data shape in the sense that this gives you the number of rows and the number of columns in your data. So first and foremost, the function is returns the number of rows and the columns of the data you've actually provided. So in this case, the output of the second function, fourth function takes in as the argument. So we define the name of the function as get shape, then data, then print a message indicating that we are displaying the shape of the data, then use the shape attribute of the data frame data to get and print the number of rows and columns. So when you do this, what this function will show is it will show you the number of rows and number of columns in that data set that you've provided. Then let's run. So everything is fine. So in the fifth functions, we define a function called check missing values. So we want to go through the data itself to know if we have missing values. Missing values are ubiquitous in the sense that virtually in all data you're going to have missing values or some weird values that they're just going to turn your efforts upside down. So if you don't check them and then know if they exist in your data, so we call that, then this function takes in data as its parameter. So this function is used to count and display the number of missing values in each column of the provided data. So now we define the name of the function, check missing values, takes in data, then print a message indicating that we are displaying the number of missing values. Okay, then use the is none method of the data frame to create a Boolean mask. How does this work? What this will actually do is that it will go through each of the rows of the data, then check if a particular value in the data is none. So if it's none, it's going to count it, indicating whether each element in the data frame is true or is not, which is false. Then use sum method to count the true values in each column and print the result. So what this function will do basically is that it will search the data that we've actually provided to this function. It will search each by rows and columns. So after searching, it will check, is it null? If it is null, then it will count it. The first one, the second one, third one. So it will count for each columns and then sum them up. So we run it and everything is fine. So in the sixth functions, we're going to be dropping the missing values that we have found in the previous function. So what we do basically is that we define the name of the function, which is drop missing values, then takes in data as its argument. Then we use the drop num method of the data frame to remove rows with missing values and store the resulting data frame back in the variable data. So how do we do that in Pandas? So we use drop num, then assign that to data, in the sense that we are updating the data. So it drops the missing value, then returns new data without missing values. So we're going to have a new data in the sense that we no longer use the data that was actually returned by the second functions anymore. So if we run it, so everything is okay. So it has already removed the missing values from our data. And we can proceed with our analysis and further exploration of our data. So in the seventh function, we want to get the data types of our data. So and the function display the data types of each column in the provided data. This is very important, because working with the wrong data types could actually result into serious issue for you, because when you know that okay, this column is categorical or numeric, so that is it quantitative or qualitative? So knowing that will help you to know the columns that you'll be performing some analysis. There are some analysis that you can perform on categorical that you can perform with continuous, or vice versa. So this function will actually show you that okay, this column, this is data type, this second one is data type. So knowing that will help you to know the structure of your data. So we define the name of the function, then we take in the previous data, this one, so as the argument, then print a message indicating that we are displaying the data types of the columns, then use the datatypes attributes of the data frame to get and print the data types of each column. So what this function does basically is that it just print out the data types of each of the column in your data. Let's run and see it. Yeah, so everything is okay. Then we move on to the next function. So in the eighth function, so it's all about the summary statistics. Summary statistics is a way of getting to know the basic structure, the distribution of our data. So the function is used to check the summary statistic for the numerical columns in the data you've actually provided. So we define the name of the function, summary stats numeric data. Okay, then we print a message as usual. Then we use the select datatypes method with include numpy.number to select only the numerical columns in our data. How does this work? The select datatypes is a very powerful method in in Pandas. So what it does is that it enables us, it goes through each column of your data and then pick out the data type that you are actually interested in, maybe categorical data or numerical data. So then we use the describe to calculate and print summary statistics for those numerical columns already selected by this method. So we print out, and how do we do that? Data dot select the types. Then the argument to be supplied is include equals to numpy dot number. If you put object here, it's going to go for categorical columns. Then dot describe to give you a summary statistics of each numerical columns that you've actually selected. So let's run this. Like I said earlier, you're not going to see any output until we call the function. Okay. So in the ninth function, what this does is that is also in form of doing a summary statistics, but for categorical variable in this sense. So we've worked on the numerical columns. Now we want to work on the categorical variables in our data. So, and what do we do? Now, normally we do unique value count for the for each categorical variable in our data. So, and how do we do that? We define the name unique value categorical, then takes in the data as the argument. Then, so what we want to do right now is that simply because we may have more than one categorical variable. So this implies that we have to iterate. We have to iterate through each of these categorical variable. So for column in data dot select the types include object, that is categorical. So if this column is categorical, then first and foremost print this column. We want to know the name of this column. Then use the value count method to count unique values and their frequencies in the current column, and then print the result. So how do we do that? Print is equal to data. Then we use this column as the iterating variable. So it will only work on this column that we've actually identified here. Then do the value counts, then print out. So this print is only just to create an empty line for separation between columns in case we have several columns, several categorical columns. So let's run and see. So everything is okay. No output yet until we call the function. So we're going to do that later, just in a few minutes. So in the 10th function, we're going to be plotting histogram of our numerical columns. So, and we take in the data as the argument. So it only plots histogram for the numerical columns. Then we can see the frequency of each of the numerical columns. Then we define the name, okay, then takes in the data. So we select the numerical columns using select the types and include numpy.number. So how do we do that? Numerical columns is equal to data.select the types include numpy.number.columns. So what this line of code actually does is that it actually assign the number of the numerical column. So this actually create a list of the name of each of the numerical columns, then assign it to this variable called numerical columns. So what we want to do now is that we iterate through the numerical columns and create a histogram for each one of them. So for column in numerical columns, that is, then create a new figure and set its size. Let's say we want to use 4 by 3. Then use SNS.isplot to create a histogram with specified options. So we could actually include many other parameters such as number of bins, KDE, and color. So, and how do we do that? SNS.isplot specify the data for this column, the column we are using to iterate, then bins 20, KDE true, then color brown. Feel free to specify your own parameters. Then we go on to customize our plots, such as putting the labels and title. Then plt.show. So let's run and see. So everything is okay. I say again, nothing will show until we call the function. So for the 11th function, we're going to be creating a bus plot. A bus plot is very important in exploratory data analysis because you could easily just track outliers, know the 5 numbers statistics of your data of each of the columns. Then from there you can actually note down many interesting stuff about your data. So this function make such a plot for you by simply just putting the data. It does all the magic. So we select the numerical columns as usual. So these are just repetition of codes, and it's important because the more you do it, the better you become at it. So these are what I came up, and these are codes that I use on daily basis for my data analysis project. Virtually on daily basis, I do exploratory data analysis. So numerical columns is equal to data.select. I've explained this earlier. This only creates a list of the names of each of the columns that are actually numerical, then assign them to this variable called numerical names. Numerical columns. Then we iterate through numerical columns and create a bus plot for each one of them. So for column, in numerical columns, we specify the figure size 4 by 3, then use SNS.busplot. We specify the x-axis, so which is data for the column we are using to iterate, then color light green. Feel free to specify your own customization parameters. Then we put S label, Y label, then the title. So this is a string formatting, and I don't think you should have an issue with that if you work with Python. So bus plot of the name of that numerical column will be substituted here. Then we display the plot. Then let's run and see. So everything is fine. So for the 12th function, which is for correlation analysis, correlation analysis is one of the key and the key backbone of exploratory data analysis. What this actually shows us is that it shows us how the variables actually correlate. Is there any relationship between a particular variable and another one? For instance, let's say the manager walks up to you and say, "Oh, could you please, Adebayo, show me probably to see how the promo we actually give to people influence our price, influence our sales and the like." So they just want to see some kind of correlation analysis. So this is when this analysis actually comes into play. So it's very, very powerful, and it's important for you to include in your exploratory data analysis. So how do we do that? We define the name of the function. Okay, then we calculate the correlation matrix for the numerical columns using this function called. Then we can assign that to this for variable name called core matrix data.select data include the numerical columns, then dot core. So this way create a correlation matrix of all the numerical columns in your data. So we indicate the figure size, then sns.heatmap. We create a heat map by supplying the data set. Core matrix is what we have here. This is the variable name that we assign this to. So then we indicate the CMAP one, annotate, just include the values of the correlation coefficient, then to two decimal places, then color bar is equal to true. Then you put the title, then display the plot. So if we run, yeah, cool, everything is okay. On to the next function. So the 13th function makes a scatter plot of the numerical columns against a particular target variable of your choice. For instance, you may want to study how price of a particular product relate with some factors, with some with some factors. Like for instance, I want to see how the price changes with let's say location, or with other parameters. With other parameters, it may be of interest. So that is what you supply, the factors, then the target variable you are interested to study against these factors. So what this code actually does now is that it goes through all the numerical columns in your data, excepting the target column. So how do we do that? Numerical columns is equal to data.select datatypes include. I've done this before in some of the previous functions. So we have the names of each of the numerical columns assigned to this list numerical columns. Okay, then we want to exclude the target column from the list of numerical column because it will actually include it here. So for us to exclude it, because we don't want to study the target column, of course, against itself. So numerical column is equal to numerical columns. Then use this to slice it, that numerical column in this sense is not equal to target column. So what this will now remove, to remove the target column from this variable numerical columns. Then we iterate through the numerical columns and create a scatter plot for each one against the target variable. So for column, in numerical columns, figure size, let's say 4×3, then use sns.scatterplot, indicate the S column, the S axis, which is our column, the column where the factor, then Y is the target column, so which is our target variable, then data is equal to data, V is the column. So these are just some ways of making your plot more explicitly informative. Okay, so then palette, I like if you read this. Feel free to modify it, to change for your own choices. Okay, then we customize the plot as put in the X label, Y label, then the title of the plot. So this will actually show you scatter plot of the column versus the target variable. then plt.title layout. This makes the plot appears a little bit more readable for you. Then go show. Then let's read and let's run it and see if we have any issue. Okay, cool. Everything is fine. So now we have completed uh, creating functions that we actually need for our versatile explorative data analysis. So the only thing we have left now is just to be supplying data. Use it as multiple times as you like. So we supply data, then run the code. So it will do all the analysis, all the 13 analysis on your data, and then give you your results. Of course, you will have to do some modifications. Probably you want to change your the variable, the target variable, the number of columns to study. So feel free to do all those and then rerun your versatile EDA code over and over again. So I'm going to be using healthcare dataset stroke data. So I actually got this from Kaggle. So, and I'm going to leave the link in the video. So feel free to download the data from Kaggle and then repeat the analysis. And also you can use this for any type of data. I can say it again, any type of data. So you may just need to do some modifications to your code, very few ones, very like maybe 1 or 2 lines of code, add to your code and then run it again, and then you have everything running again. So I'm supplying this data set, and what I'm going to do is that I will run, these are the functions. So I'm going to run all the cells at once so as not to waste my time, or we can go ahead and run it one after the other. Let's say yes, we run this, then everything is okay, it has loaded the data. Then we want to display the head of the data, the first 5 rows that we indicated. Cool. So this is showing us the first 5 rows of the data. Then the next function is get the shape of the data. Let's run. So this is telling us that we have 5110 rows and 12 columns in our data set. Then let's check for missing values. This is showing us that we have no missing values in our data. Good luck for us. So then another thing we want to do now is to drop the missing value, and simply because we don't have any missing value, of course nothing will be affected, so you won't see anything. Then another thing now is you want to get the data types of the columns. Let's run this. Cool. This is one of the most important parts of exploratory data analysis, getting to know the data types of each column in your data set. So the ID, the gender, and the like. So in some cases, Python assign wrong data type to your data. So from this, you can easily just identify the column with wrong data type, then immediately convert it to the actual data type of that of the content of that column. So this is why checking data types of each column of your data is very, very important. So the other thing we want to do now, the function we want to call now, is summary statistics of the numerical columns. We run this. Yeah, so this is what we have in our column in this function. So this is actually showing us the summary statistics such as the count, the mean, standard deviation, minimum 25%, 50%, 75%, and maximum of each of the numerical columns. So this is very, very important. So from this, you can easily see the some key summary statistics of each of the columns. Then the next function right now is to get the unique value count and the frequency for the categorical columns. Let's run it. Cool. So this is telling us that we have 2897 female, male 2011, and other 1. Then for this column called ever married, yes, 3204. So these are important informations, very, very key for you to proceed with your modeling or to answer the business questions being pushed to you by the managers or whatsoever that you are reporting to. So the residence type and smoking status and the likes. So we've already gotten some statistics about numerical columns. This is about the categorical columns now. Okay. So on to the next function. We want to plot the histograms of the numerical columns. Let's run it. Yeah, cool. This is actually showing us the distribution that we have within each of our numerical columns. This is histogram of the ID, histogram of age, histogram of hypertension. Of course, you can see that some of these plots, they are not needed. Like they don't they are not showing any real information like this one. So this is why I said that you might just need to select a particular number of factors that you are interested in. Okay, so it may not actually be on all the columns of your data. So this is showing the histogram of average glucose level for each of the record. You can see, so we have mainly two clusters. We have one around here, we have another one here. So this is also showing the histogram of BMI, which is quite close to Gaussian function. So then we have for stroke and the likes. So the next function right now that we want to check is the bus plot of the numerical columns. Let's run and see. Yeah, cool. So this is the bus plot of ID, and what bus plot actually shows you is it shows you the media. It shows you the media, which is this second quartile. It shows you lower quartile. It shows you the upper quartile. Then it shows you maximum and the minimum. So we call this 5-number statistics. So this is a bus plot of the age. This is bus plot of hypertension. This is because this is actually we can consider this as a classification or a categorical variable because it's only between 0 and 1. Okay, so that's why we are not having any information. So the same applies to heart disease. Why for glucose level, excuse me, for glucose level, we can see some high level of outliers. These are outliers that you are seeing here. These are also outliers. This value you are seeing, these are outliers. So you can see now that there are some outliers in your data. So, and you may need to pay attention to why you are having the outlier, what the information the outliers are actually passing across to you. Then the next function right now is to do the correlation analysis of the numerical columns. So let's run it. Yeah, cool. So this is actually showing you the correlation matrix of each of the numerical columns. So you can see how each of these column actually correlate with another. So alpha glucose level, how does it correlate with BMI? Let me see. Does it correlate with BMI? Not so well. How does glucose level correlate with the age? 0.24 and the like. So no strong correlation uh, with this within these variables. So you may have other data that you may want to study their correlation analysis. So that is when this function comes handy for you to use. Then we call the last function right now, which is the scatter plot of numerical columns against the target variable. Okay, so let's run. Nice. So this is the scatter plot of the age. In this case, I'm actually indicating age. So this will make a plot of y-axis age against each of the numerical columns in our data. So, and the effect of we that I actually indicated the other time is this diversion of the colors that you have here. Then this is another. You can see a sense of clustering here in the scatter plot of IV glucose level versus age. Within here, then we have another cluster somewhere here. So yeah, this is a way for you to just have an overview of your data. Then this is another interesting information. These are outliers. These are outliers, and you may want to ask yourself, why do we have this outlier here? So do some further analysis, and you can see the structure of scatter plot of BMI versus age. So basically, this is what versatile exploratory data analysis does for you. And I think you've learned one or two things in the code. I'm going to make the code available on my GitHub account, and feel free to fork it. Feel free to download, use it, modify, edit it, and use it for your daily basis data analysis project. And please don't forget to like the video. Don't forget to subscribe. Don't forget to share with your friends. If the channel is actually helping you, uh, I hope you also be able to help the channel to grow by doing the necessary steps. And I don't think that should take too long or should cost you anything to do. So please, I'm appealing to you to please subscribe to our channel. And it's a relatively new channel, and it needs to grow. And that's why we are providing this kind of free information for everyone that is interested to make use of it and to also learn, and we can grow together. So feel free to improve the code for your own use. Okay, thank you so much, and see you in the next video. And of course, I'm going to be coming up with the R programming version of this versatile exploratory data analysis code. I have it already, but not yet organized. So I need to organize the code just the way I did for this. So I will organize the code, then make a video on that for you to see. And also, probably your project requires you to use R programming language, so you can easily just switch to R and then get your job done. Thank you. See you in the next video.